Today we'll be studying redox reactions and the electron balance method for equating them. This topic is essential in understanding chemical reactions. So, the first example occurs between copper oxide in orientation 1, sulfuric acid in solution, and the reaction produces a salt, copper sulfate 2, you get sulfur oxide, it's a gas, and water. Water is a substance, in this case a liquid. So we need to pick up the coefficients by the electron balance method. Now, let's start with the first step, which is to remember that we are following an algorithm in this case. The initial step is to identify the oxidation degree. To do this, we refer to the periodic table and observe that oxygen carries a charge of -2, while copper carries a charge of +1, according to the rule of the cross. In the compound H2SO4, oxygen has a charge of -2, hydrogen has a charge of +1, and with the help of a balanced equation, we find sulfur has a charge of +6. Moving on to CuPrOm-CO4, oxygen has a charge of -2, copper in this case carries a charge of +2, resulting in sulfur having a charge of +6. This is when we should acknowledge that if the acid residue remains unchanged, the oxidation degree charges will stay the same. In CO2, oxygen carries a charge of -2, which means sulfur carries a charge of +4. Lastly, in H2O, oxygen again has a charge of -2, and through the rule of the cross, hydrogen carries a charge of +1. The next step involves determining which elements have exchanged charges. That would be copper, underline, and sulfur undergo a change in oxidation state to +4. The next step involves creating two half reactions. The first half reaction is the transformation of copper from +1 to +2. Since the copper on the left side has a coefficient of 2, we will also assign a coefficient of 2 to the copper on the right side. Therefore, from +1 to +2, copper needs to release 1 electron. However, with a coefficient of 2, it will release 2 electrons. Traditionally, we represent the release of electrons on the right side, indicating that in this case, the oxidation state is +2. The shift in sign will occur in reverse if the reaction is reversed. Additionally, let's consider the next element, sulfur, which changes from +6 into sulfur +4. Sulfur will thus accept 2 electrons in order for this transition to be possible. Now, we take the numbers we found across the line. The number of electrons given and electrons received, we have got 2. They are reduced to 1 and 1, and the copper acts. Since it will give up electrons, this process is called oxidation. And for sulfur, this process is called reduction. And copper in this case is called a reducing agent. Abbreviated, we write it this way: sulfur will be an oxidizer. We write it down like this. We put the numbers we found as the prime factors. 1 will go in front of copper. And let's put, although usually the unit is not put, but to make it clear where it will be this coefficient, well, before sulfur the smallest will go here. Looking for the auxiliary. Medi on the left side is 2, on the right side is 1. We put a factor of 2 in front of the CO4 cube. Now count the sulfur. There's 1 sulfur here on the left side and 3 on the right side. We put the quotient in front of the formula for sulfuric acid. 3. Then hydrogen on the left side is 6, on the right side is 2. We'll put 3, oxygen. Oxygen here is 1 plus 12, 13. On the right side, that would be 8 plus 2 plus 3. So that's 13. The equation is equated. Next example, zinc reacts with sodium nitrate. In the presence of sodium hydroxide, sodium zincate, ammonia, and water are obtained. Put the degree of oxidation. Simple substances. Charge 0 in sodium inside oxygen -2, sodium +1, and nitrogen will be counted through the equation get +5, the zero-sum method. In sodium, oxygen -2, sodium +1, hydrogen +1. In sodium 2 zinco, 2 oxygen -2, sodium +1, and zinc will be +2. In ammonia, nitrogen is -3, hydrogen +1. In AgO, oxygen is -2, hydrogen +1. Changes the oxidation state of zinc, and nitrogen changes its oxidation state. So we make up the first half reaction. Zinc goes from 0 charge to zinc 2+. On the right side, we express zinc losing 2 electrons by writing +2, and the same applies to other elements. Next, nitrogen from +5 goes to nitrogen with a charge of -3. The degree of oxidation decreases, so it will accept 8 electrons. So we take the number we found to be 2, 8, change it crosswise to 8, 2. And as we can see, these multipliers are reduced, so it's 4 and 1. Zinc is a giving element, undergoing oxidation, which involves a process. And he's going to be the reducing agent. So nitrogen will be a reduction process. And it will be called an oxidizer. We'll put the multipliers we found, 4. Will go in front of the zinc formula, 1 in front of the ammonia formula. Next, zinc on the left is 4, on the right is 1. Put 4, nitrogen on the left one, on the right one, sodium on the left one, +1, 2 sodium, and on the right 8, so there's 1 here and still missing 7. Put 7 in front of sodium, OH, hydrogen 7. There's 3 and there's 2, 5. To equalize the 7 and missing here, put in front of the water formula would be a factor of 2. To ensure oxygen balance, we perform an evaluation. The sum of 3 and 7 equals 10, while 8 plus 2 also equals 10. All equations are equalized. Today we explored the electron balance method and analyzed 2 examples. Hoping for comprehension, we bid farewell.